are going to do one very interesting and very important reaction, that is synthesis of OFF, off. Also, it is an insect repellent. Alright, this is our experiment number 20. And as we discussed in the pre-lab discussion, the off is synthesized by the reaction of the acid chloride or the benzoyl chloride with the diethylamine. But before that, see, this is the toluic acid. All right, we could use the toluic acid also and react with diethylamine to get this N-N-diethyl toluamide, that is off. We could prepare that by reacting this with directly with this one, so that OH of this and hydrogen of this will go away and you get this product there. But however, this toluic acid is somewhat less reactive compared to the tolulyl chloride. Therefore, this carboxylic acid is first converted into chloride, acid chloride, by reacting with thionyl chloride. Be careful, thionyl chloride is carcinogenic, so we will be using that very carefully. Okay, this toluic acid, metatoluic acid, reacting with thionyl chloride, we will get the acid chloride. The side product, sulfur dioxide and HCl, that will remove as gases, so we don't need to worry about that. Once this chloride, tolulyl chloride, is formed, then it is then reacted with diethylamine. Now HNCl, the hydrogen chloride, will be removed from that. That is when it will form the NN. Nitrogen has both ethyl group. That is why it is called NN diethyl meta. This is in the meta position, metatoluamide. That is what we call off, or also known as DEET, DEET. All right, this is how it is synthesized. This is the reaction to synthesize that. We discussed the mechanism in the pre-lab discussion section also. Just only I wanted to make your head up how this is prepared. All right, so we will go to the bench for the reaction. We synthesize off in the reactions. For that I use this 10 milliliter small round bottom flask with a stir bar in here, and I add 0.4 gram of metatoluic acid. So metatoluic acid is here, and I took 0.4 gram of metatoluic acid. So this is what I have already weighed. So I just add that in this reaction flask there. Now I need to add excess of thionyl chloride, little more than 2-fold of thionyl chloride. So we need to do some calculations, and I have done that here. 0.4 gram of toluic acid, which has the molecular mass of 136.15. So the number of moles is 0.00294 mole. Since I need to use almost 2-fold excess, so I will need approximately 0.0058 mole. And the molecular mass of thionyl chloride is 119 gram per mole. So if I convert this into gram, that will need 0.6992 gram of thionyl chloride. Now thionyl chloride is a liquid, therefore I use the density 1.64 gram per milliliter. Therefore I will need to add 0.46426 milliliter of thionyl chloride by using the density equal to mass by volume calculation. That is how much I will need. But since it needs to be used in little bit of excess, I am going to measure 0.5 milliliter of thionyl chloride. And as I said earlier, thionyl chloride is carcinogenic, that is stored under the hood. So we take that by using the this small syringe. We measure 0.5 milliliter. So this is thionyl chloride, as you can see here, thionyl chloride. I will pour a little bit here in this. See, it is fuming. You can see that there. You don't want to smell this fume there. So we will use little bit of this here. And this is how much I take here. From here, I will use 0.5 milliliter. 0.4. Yes, this is 0.5 milliliter of thionyl chloride, and I am going to add that here in the reaction flask. Okay, so this is 0.5 milliliter of thionyl chloride and 0.4 gram of toluic acid. All right, so now this needs to be heated in the here. So the apparatus setup is here. That is what I have shown here. So I will put this here in the condenser. So Claisen condenser here. So I will clamp it here, and that needs to be heated to the temperature of about 90 degrees Celsius. So I use the water bath. So this water is already preheated there. So I need a temperature of around 90 degrees. So it's all approximately boiling. So 100 is the boiling point of water. So I lower this little bit so that it will be on the inside the water here. So I will heat this water just to boil that so that the temperature can get to the 90 degree Celsius. So this is how the setup is done. Now on the top of this, in order to avoid any vapor going around, we use this calcium chloride drying tube also, so that the moisture cannot get in there. So this is how the setup will look like. Okay, we have been heating this for last 15 minutes. So at this time I will turn off this hot plate. I need to remove that from the water bath. So I will just quickly remove this from the water bath, because it is supposed to be heated for 15 minutes. So it has been more than 15 minutes. Let me remove this from the water bath. Right. Now next what I need to do here is we need to add 4 milliliter of ethyl ether or diethyl ether to this reaction mixture. So I will bring 4 milliliter of ether that we can add through this small shape funnel. So that will go and we'll add into this one. So let me bring 4 milliliter of ether here. So this is anhydrous ether, that is 4 milliliter. That is what I will add into this solution from this small separatory funnel. I will let it add everything there. Okay, so 4 milliliter of ether is added into this one. We have added 4 milliliter of anhydrous ether into this one. Now, in order for this reaction to proceed, we need to add excess of diethylamine. Now, diethylamine, we need to use at least a 3-fold excess of the toluic acid. And the calculations is like this. Here we use approximately 0.003 moles of toluic acid. So 3-fold means 0.009 mole. That is how much diethylamine we need to use. The molecular mass here is 73. So to convert that into gram, that will be 0.657 gram of diethylamine. Please take a note on these calculations. Okay, you need to be very comfortable with this kind of calculations there. So this is the gram. Now, since the diethylamine is a liquid, we need to find out the volume. Density is provided there, 0.71 gram per mole. So when we calculate the volume, it comes to be nearly 0.925 milliliter. So this little bit excess, so we will take 1 milliliter of diethylamine, and that will mix with 1.5 milliliter of ether, and we will take that in a small small tiny separatory funnel, and so that we can use the addition, drop-wise addition onto the reaction mixture. So that is our plan. So let us take the required amount of the materials there. So here we use diethylamine. Again, this is under the hood here. So we use, this is diethylamine. You can see we need 1 milliliter of this. So just I pour a little bit here on this small beaker. Let me close this quickly, and again I will use 1 milliliter of this here. This is the syringe that I have, that is for 1 milliliter. So let me okay, this is 1 milliliter. I will use this in my small safe funnel. It is in the closed position, so this is good. I can use slight excess there just in case, because this is again excess of diethylamine, so just in case I will use a little bit more here. So that is diethylamine. Now I need to use 1.5 milliliter of ethyl ether or diethyl ether. So I have the syringe for that measurement also. I pour a little bit here. So it is 1.5 milliliter. Again, that is approximately, since ether is the solvent, so it doesn't have to be exact. So I mix that here. It's almost 0.75. I will take that twice. So I will add this here together. And another 0.75. So that will make approximately 1.5 milliliter. Again, this is just the solvent, so it doesn't matter if it is slightly less or slightly more. So this is the mixture of diethylamine in ether. Now this reagent that needs to be added drop wise, that is why we are using this small safe funnel. We could use drop by using the syringe also, but that is a little bit tedious. So if we use this, we can set up for the drop wise addition. So let us go to the reaction there. Now this is where I will just quickly replace this with our separatory funnel. So I need to set up for drop by drop addition. Okay, let me open it. Again, we need to do drop by drop addition. This is the complicated process. So diethylamine, it will start giving the fume here though, so that's why we need to be very cautiously added. See, you see the fume forming there? You can see that here. So this needs to be added very carefully, drop by drop. 10 minutes now. Now it is time to add some sodium hydroxide. So what we need to do is, see, we have here 5% sodium hydroxide, and it is 2 milliliter. This is 2 milliliter. That is what I took from that bottle, and this needs to be added. So I will just use this separatory funnel to add this also. So I add this 2 milliliter here. And I will let it add from this one here. Just I open this, so this will be added to that reaction mixer. Okay, this 2 milliliter of sodium hydroxide is added there. Now after adding this sodium hydroxide, this needs to be stirred for 15 more minutes. So let me add everything here. Okay, now this needs to be stirred for 15 more minutes. So we go 15 minutes stirring in this mixture. I've been stirring for 15 minutes, so we are all done with the reactions here. Now this is the reaction, so I will turn off the stirring also. Here is our product. Okay, so in this round bottom flask we have our product there, and it will form a 2 layer. So we can see that in the round bottom flask also, but it will be more visible if we transfer that in this separatory funnel. For that I will use this small or mini separatory funnel here. So that is what we have here. So it is kind of very comfortable in using that. So this is the separatory funnel that we use for this purpose. Okay, so here this is where I will transfer my reaction. So let me put that in the closed position, and I will transfer this here. I don't want to drop this steel bar. That's why I'm trying to be a little bit extra careful here. So I wanted to transfer only the liquid part here. Okay, that's good. So the steel bar is here. So you can see two layer there. So lower is the aqueous layer, top is the organic layer, and our off is in the upper organic layer. So what we need to do is we wanted to separate the lower layer here. So just I will draw off this lower layer in this tiny earthenware flask. So we don't need the lower layer though. We need the top layer. So just I will transfer that here. I wanted to close this immediately here. So a little more. Okay. All right. So this is the organic layer. Now I need to add 2 more milliliter of sodium hydroxide in order to clean the product here. So this is sodium hydroxide again, 2 milliliter. This is what I will add in this mixer there. So you see some fume is coming here. And we need to do some shaking here. So this is the cap that fits perfectly. So I will just quickly shake, and then I will allow the vapor to go out for a second here. Do one more time. This go away. All right. Now this lower layer again is the aqueous layer. That is what we don't need. So I will put the aqueous layer together. In this previous aqueous layer, we mix them together. So that I will draw the aqueous layer. Looks like it is good. But there's some aqueous layer. Let me put this in the clamp so that I can handle it little comfortably. So 1 second here. Let me clamp this so that I can do little more carefully. Okay. So this is where I will clamp it here. Or this position, maybe this is better here. Okay. Now it's much better. Yeah, a little bit I can draw there since there is a one extra amount of. Okay, that's good. Yes. So this is where I have my off there. Okay. Now after sodium hydroxide, this solution, then we will do the extraction with a hydrochloric acid, or cleaning with hydrochloric acid, we can say that. So I use 2 milliliter of hydrochloric acid here. That is 10% HCl. So I will just add that into this one. Okay. And do again that same mixing process that as we did earlier. So quickly separate the layer. Shake quickly. And we can separate the layer there. As you see, it is forming 2 layers. I will allow it to set it for a couple of seconds there. I think it is a very good separation. As you can see, clear 2 layer there. Now the lower layer, I will mix that with the aqueous layer previously we have here. So just I will draw the lower aqueous layer out. All right. After hydrochloric acid, I need to repeat this process with distilled water. Again, I use 2 milliliter of distilled water. This is DI water or distilled water. So just to wash with water, 2 milliliter. Again, I will shake that so that any acidic or basic component will be gone. So just clean that a little bit here. It will form 2 layers. This layer is separating very clearly. All right, so let me set it on the stand here so that I can make a clean separation of that. So the lower layer, I need to draw that out. There we go. Now this organic layer, we need to dry this any moisture present in that with the anhydrous sodium sulfate. So here is anhydrous sodium sulfate. We could use about 0.5 gram depending upon the amount of solvent, but again I don't bother in weighing that. Just I will take a little bit of that approximately. It's just a drying agent, so this should be good amount here. Just I will use that here, okay, so that can absorb any moisture that may be there on this organic layer, on the ether layer. So this is what I will pour this here. Again, I will use the from the top. I will pour this organic layer here, okay. So any moisture that is present here, that will be absorbed by the sodium sulfate. In the meantime, that I wanted to get that product out in this tiny beaker. So to get that product, I will first get the mass of this empty beaker. So it's a small 10 milliliter beaker. I will take the mass of this. So I will go and record the mass there, okay? Okay. So here, the mass of this empty beaker is, make it 0 first, we go 8.444 gram. So I will just take a note on this one. Mass of empty beaker equals to 8.444 gram. This is where I will put our product there, okay? So let's transfer our product only, not the solid. So this should be dry by now. So this only the liquid part. I can do the decantation, or I can use the pipette to transfer that, but since liquid can be clearly separated, so I will just transfer that here. Okay, here is my product. The sodium sulfate will remain here. Now this product is in ether, so we need to evaporate this ether in this hot plate. Just I will heat this very in the low heat, and we heat that in order to evaporate the ether part. That is where we will get our product. All right, so almost all the solvent has been evaporated. So we got this the product in off in this small beaker. So we wanted to know how much product we get. So we have the mass of the empty beaker. So we will go and get the mass of the beaker plus product. So we quickly get the note on this mass here. We grab the pen. So we have here that will be here 8.545. yes, so mass of beaker plus product, that is off, okay, it is 8.544 gram. So you see here 0.100 gram is how much product you have for the off. Okay, so this is the crude product, and we could recrystallize by doing the column chromatography quickly by using a very mini column in the Pasteur pipette. That is what your manual has suggested, but considering the amount of the product, we will not go to that part. We will take the IR and the NMR of this product, and we will characterize that. And again, the product is very clean, and we have done the extraction, so there should not be too much of the impurity there. So this is a clean product. Okay, we will do the IR and NMR of this product, and that is what you will characterize. So once we isolated the product off, that we need to characterize by doing the IR and the NMR spectroscopy. So here we are for the IR. So in order to do the IR, as you all are aware, that we need to take the background first. Background means the atmosphere or the crystals, whatever is there. So we need to take the background first, and then we take the compound spectra and we subtract the background. That is the usual procedure. So I have collected the background. So we wanted to add to window 1. So we say yes. So this is the background in window 1. Now to have our product IR, so we go with the new window. So that is where we will collect our, so window 2, that is okay. So this is the window, that is where we produce our sample IR. Okay, so I use it, this is a kind of liquid sample, so I will use this tiny pipette to put the sample in the crystals. So I will use this small amount of the sample here in the crystal. That is what I will apply there. So here is the sample, very small amount. That is what how much we need to put on the crystals. Okay, so that is more than enough here. Okay, let me add one more drop. Okay, so this is the sample for the IR. Now we lower this tower until it hit click. So we just hit click here. Okay, so once we do that, we secure this sample here, and we collect the sample spectra here. So COLSMP, that is where you want it to click, or even you can do that, this collect and collect sample, anyone, both is the same thing. So you can do collect sample. So this is the OFF of product IR. So that is the name I just gave here. So that is, I will hit OK. So please prepare to collect the sample spectrum. We are ready. So just hit OK. And it will start collecting. It needs to go 16 scan. So it is going like 2, 3, 4. So that is how it will go 16 scan. This is the IR spectra of your product. It looks very, very nice and clean. Okay. So that is the product. So it will go until 16 scan. 12, and then yes, so it will say A to window 2, we will say yes. All right, now this is the observance. So we wanted to make that in the transmittance. So process percentage transmittance. So this is how it looks. Now make it look nicer, you can do one more thing here, process, that is called baseline correction. To make it look nicer, it's not necessary, but just to make it look nicer. So just click here. So make it a straight line, right? Instead of going this down here, just want it to make it straight. Just hit click here. Yes, and then replace. So this is the IR spectra. Now you wanted to find the peaks, the value of these various peaks there. So you can raise the bar this little bit. So that is how you find out the peaks there. Okay, so you need to learn how to do the IR also, and just make it replace. So this is the IR spectra of your product. Now we can just quickly print one copy of that. So just print there, and that is in this one, and just print. Okay, so this is the IR. After IR, now the next, that is what we are going to do, is the NMR, proton NMR of our product. And for that you need to seam the instrument. That is what I have done there. So it is ready to use. So just I will click there, and so I wanted to take the proton NMR. So this is where the proton NMR I will use. So that is the thing. So this is not the spectra, by the way, this is for the other samples there. Okay, but we will prepare the sample first. All right, so this is the sample, and very small amount of sample is needed. So this is good amount there. Just I will use few drop there, couple of drop here. So that's more than enough. All right, now for this I need to dissolve in a solvent. So I will use CdCl3, deuterated chloroform, for that. So just take this sample chloroform there, and I will use that here. Okay, maybe a little bit more. Okay, once I make this, I want to make this in the solution here. It's a very transparent, clear solution, and I want to use this NMR tube. This is where I wanted to load my sample solution, and yeah, that is more than enough. So whatever is here, just add that. Now I wanted to use the cap to close the mouth of this. So here, now I need to make the measurements to make the height here. So I just load it here and just make the measurement here. Okay, you can push it a little more here, so that is good. So this is a good height here. All right, now here is the standard. So that is what I'm going to replace this by my sample here. Okay, so this is the step that is where we need to be very careful not to break the tube. All right, so once this is there, now see here the solvent, that is chloroform, and the sample is unknown. Now we are going to do the proton NMR. That is where I hit start. So that is when you will see the spectra. So do you want to continue? Yes, we want to continue that. So this is where you will see the NMR spectra of your sample. There we go. So it is a little bit noisy because of the little bit more dilute, but that is okay. You can see the peaks, very nice peaks there. So it is still scanning, so it will come even better. All right. You need to characterize what are these peaks for. Okay. So it's still scanning. So it will take a couple of more seconds to finalize this. So you need to characterize what are these peaks for. It's a very nice spectra actually. You should be able to pinpoint what are those. All right, so this shows that it is done. Just I will write the name of the sample here. Just I will put the comment. So the comment is of product, and this is NMR. Oh, product, sorry. Just load, so that is off product NMR. All right, so that is it. So I just need to print this out. So I will just get the PDF and I will put this NMR in your D12s, and you need to characterize all this NMR also. Okay, so file, I will just print that. That's it. You have the NMR, you have the IR of your product, and you need to do the characterization with this. Okay guys, thank you. Yes.